Awesome.
I'm glad. I thought this project was going to be more of a hassle, but it's not, which is nice.
I know, right?
And what did you do with all your... Sorry, go ahead.
Oh, I was going to say, I think I'm going to start probably working on the PowerPoint maybe this weekend.
Nice.
Try.
Yeah, that'd be awesome. What did you do with all your Skittles?
They're sitting in my closet, my pantry right now. I think I'm going to give them to my brother and have him give them out to his primary class.
Oh, that's a good idea.
But I'm kind of waiting for a couple of weeks because I'm not sure if we're going to need the information yet. Still from the And then I think I might give some to my brother-in-law and that because he's big on food and candy and that. So I might send some home with my sister.
There you go. That's a good idea. I'm like, I have all these Skittles sitting in the bowl on my counter, and I'm like, I'm either going to throw them away or I need to give them to somebody because I like Skittles too much. I'll just sit there and eat them.
I know. It's my problem too.
Okay, well, going to do the quiz. Are you ready for this?
Yeah.
Okay. So given the linear regression equation, y equals 2 plus 1.5x, what is the y-intercept?
Isn't it 2.0?
Yeah. Same equation, what is the slope? Just 1.5?
Uh-huh.
Okay. Given the linear equation, what is the predicted value of y when x equals 16? Okay. Oh, I got one.
I did too.
Okay. For the next 7 questions, use the data math self-efficacy. Be sure to use the confidence data for the explanatory variable and the score data as the response variable. Make a scatter plot of the math self-efficacy data of the 3 data shapes introduced in the reading. Which shape best describes these data? Okay, let's see. Confidence. So I think it kind of looks like a hot dog.
I would agree.
I'm trying to, just before I forget, I'm going to look up what the hamburger, I don't remember what the hamburger looked like. I still think it's a hot dog, but I can't remember what.
Yeah, there's more spread out.
Yeah. Okay. Cool. Question 7. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? I would say it's appropriate.
Yeah.
How many observations are in the data? That's a weird question. We haven't really been asked that before. Is it 276? Because there are 138 in each set, so times 2 is 276.
Yeah. Well, 139, actually.
139?
Uh-huh.
Oh, yeah, minus 3, right? Yeah, I think you're right.
Yeah, so 278.
Thank you, yeah, 278. And the y-intercept, 18.690.
Mm-hmm.
And the slope of 12.695.
Mm-hmm.
What is the predicted value of y when x equals 4? So that's 69.469.
Yeah.
Okay. Question 12. The confidence data resulted from students evaluating their confidence for each questions on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Because there's a positive correlation, we can use the largest x value to find the largest predicted value of y. So do we put x as 6?
That's what I think, yeah.
Okay. So 94.859.
Uh-huh.
Okay. That's a weird question too. I
Yeah.
haven't been asked that before. All right, so question 13. How many explanatory independent variables are present in simple linear regression? More than 2?
That's what I would think.
It's like way more than 2, so that's weird. How many explanatory variables are present in simple linear regression? Is that just meaning how many like data values there are in independent variables?
That's what I'm thinking. I don't remember the reading covering anything like that.
Me neither. Let me look real fast. All it says is this simple linear regression is a method used to fit aligned to data. This provides a powerful tool to model bivariative data, which is data involving 2 variables.
Mm-hmm. I would then say 2.
That's what I would say too, but I don't know. That's weird. Should we just say 2 then?
That's what I'm going to put.
Okay. Okay. Oh, well then how many response-dependent variables are present in simple linear regression? Is there 2 there also?
That's what I would think.
Oh no, wait, isn't there just 1 of each?
That's what I'm thinking too.
Yeah, I think it's 1 of each.
Let's try that one.
Because there's 1 variable
For
in each one.
Mm-hmm.
That just was weird.
I'm trying to trick you.
Yeah. Let's just say 1. So a company in South Dakota manufactures hard hats used in the mining industry that record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference to the hat, the lengths and the major and minor axes, meaning the company wants to predict the size of hat given the circumference. What is the response variable? It's the size of hat, right?
Yes.
And it's because it's the variable being predicted.
Mm-hmm.
Okay. Okay, well, we got one right. So, but how many observations are in the data?
Hmm.
Then is it just 2 observations? Because it's the explanatory variable observation and the response variable observation?
We can try that and see if that works.
Okay.
If not, I have no idea what they're asking for.
Yeah. Okay. Try that. Oh, what the heck? Why do I always do this? I opened the wrong. Oh, I opened the homework quiz. Oh, good thing I already took it.
It wasn't the test.
Yeah, that's what I did at the test. Oh my gosh, why do I always do that? Oh well, I already took the homework quiz and was fine with it, so I can get a 0 on that one. Okay, this is better. Gosh.
Still got that one wrong with putting 2.
Really?
Uh-huh.
Dang. Okay. Well, don't know the answer to that one then. I wish you would tell us the answers afterwards.
I know. It'd be nice. But I was reading this next week's lesson, and on here it said somewhere in the Excel instructions that you can find the DF, which would give you the sample size minus the 1. Oh, you have to do it as an ANOVA, I think. Out of curiosity, I wonder what that would tell me.
Yeah, don't know. I wonder too, sometimes I'm like, maybe if I
Try
listen to someone else's
277.
Try to what?
Try 277.
Oh, I
Because
actually already submitted it right when you said it was the wrong one.
oh,
Sorry.
I wonder if that's what it is, because that's what this is showing the DF for in the ANOVA test. And we put like 278.
Yeah. But, oh, because it's -1.
Uh-huh.
Okay. Yeah, maybe. I might like search through other groups' videos too and see what they said.
Okay.
Or I'll just email her. Email her about another question. So I can always email her about that one too.
Yeah, that works.
Oh well, at least it's just one.
Yeah.
All right, so we'll meet on Monday then.
Yes, Monday, 5:30.
5:30. Okay.
Yeah.
Sounds good.
All right. See you then. Have a good weekend.
Thanks, Ashley. You too.
Thanks.